I'm Erin Walsh, and these are my colleagues, Kevin Lee and Rob Clifford. Today, we are going to talk about the ways Privacy Sandbox is furthering a more private ecosystem on Android and Chrome. Historically, mobile apps and websites have relied on cross-app or site identifiers and other tracking mechanisms to support ad selection, fraud detection, identity services, and other critical use cases. However, there has been increasing concern over the years around the privacy implications of cross-app or site user tracking. This has led to big changes on the web, with examples such as the planned deprecation of third-party cookies on Chrome, and the announcement that Microsoft Edge will start experimenting with deprecating third-party cookies as well. This will have a significant impact on the use cases that currently rely on these cross-site identifiers. You can learn more about third-party cookie deprecation and how to transition out of using them by checking out the talk, What You Need to Know About Third-Party Cookie Deprecation. If your website, progressive web app, or trusted web activity uses third-party cookies to support user-facing experiences, such as login, visit our developer website to learn about the new privacy-preserving APIs to support these use cases. The current mobile and web ecosystem relies on cross-app or site identifiers to enable critical use cases, including ads use cases. Cross-site identifiers can be used to build profiles based on user data obtained from cross-app and cross-site tracking. The Privacy Sandbox is a collection of APIs to support these use cases without relying on cross-site or cross-app identifiers, while improving user privacy. Let's hand it over to Kevin to learn more about these privacy improvements.
To learn about how the Privacy Sandbox will support key ad use cases without cross-app or site identifiers, let's take a look at the Attribution Reporting API. The Attribution Reporting API is used to attribute a conversion event, such as a purchase, to an ad event like an ad click or view. For example, when a user sees an ad on one app or site and makes a purchase on that ad's app or site at a later time, the Attribution Reporting API allows that purchase to be attributed to the ad the user saw previously. Attributing conversions to ads is important to advertisers, as it is how they are able to tell that the money they spend on advertising is worth the cost. Measuring conversions requires cross-app or site data, since the user saw an ad on one app or site and the conversion happened on another app or site. We want to provide attribution insights back to the ad techs, but we also need to protect user privacy before the reports are sent. One of the goals of the Attribution Reporting API is to make it difficult to link a user's identity across two apps or sites. We always think about what net new information is provided by the Attribution Reporting API and how we can limit this so that enough information is provided by the API for it to be useful while making it difficult to link user identities. Let's take a look at Attribution Reporting API's event-level reports. Event-level reports deliver information that associates details about a source event, such as an ad view, with coarse information about a trigger event, such as a purchase. For example, an event-level report could tell you the impression ID of an ad and the publisher that hosts it, and that the person who saw the ad eventually made a purchase on the advertiser's site. This is very different from event-level reporting using third-party cookies, where the ad tech would be able to identify the exact ad impression and purchase that happened, including information like an order number or email address. Also, the Attribution Reporting API's event-level reports are limited both in how long of a gap there can be between the ad and the conversion, and the number of conversion reports that can be generated. This is quite different from third-party cookies, which can be used for nearly unlimited reporting. Minimizing the amount of data exposed to ad tech is one of the ways we're using to improve privacy from third-party cookie usage. Another method we use to protect user data is adding noise to the conversion data before the information becomes available to ad techs. For example, regardless of whether or not a user converted, the event level report received could represent a true conversion, a different conversion, or no conversion at all. Noise is added here by using a procedure called randomized response. This procedure makes it difficult for the ad tech to be sure about whether any one event they receive is true, while still allowing them to learn trends, like that the ads from campaign A are more likely to convert than ads from campaign B. Randomized response is used in many settings where it's important to provide plausible deniability. For example, imagine that you're a researcher and you want to learn about a behavior that people might find embarrassing to be honest about, like flossing every day. You could directly ask people about their flossing habits, but using randomized responses, you can ask them in a way that doesn't reveal any one person's flossing habit, but lets you, the researcher, learn about the fraction of people who floss every day. Here's how it works. The researcher will ask if you floss every day. And before you answer the question, you flip a coin. If it's heads, then you answer truthfully. If it's tails, then you flip the coin again. And if the second flip is heads, then you must answer yes, regardless of what the true answer is. And if it is tails, then you must answer no. Let's say that your true answer to the question, do you floss every day, is a yes. So, before you answer the question, you flip a coin and it comes up tails. Therefore, you flip the coin again and it comes up tails again, which means you must answer no, even though your true answer is yes. This gives you plausible deniability and allows you to say, I actually do floss every day, but the coin flip forced me to give a no answer. Because of this plausible deniability, the researcher doesn't learn very much about your flossing habits. However, as long as the researcher asks enough people about their flossing habits, they will still be able to subtract out the noise on average to learn what fraction of people floss. This same concept is applied to adding noise to the event level reports from the Attribution Reporting API. But instead of asking about flossing, the API is essentially asking about whether an ad impression converted or not. For event level reports, data minimization and randomized response with noise are some of the privacy protections we apply before the data leaves the device or browser to improve user privacy from the status quo, while providing meaningful insights to ad techs. As mentioned earlier, event-level reports provide detailed source data, such as the campaign ID, but only provide coarse trigger information, such as that a purchase has been made. However, there are important attribution use cases where an ad tech may want to use more data about conversions, but in aggregate. For example, to understand total revenues across all purchases driven from different ad campaigns. To do this, we'll need to be able to aggregate results from many different users' devices or browsers, rather than just learning yes or no answers. And this will require us to add noise in different ways. Let's suppose that you want to learn about the total spend from conversions attributed to an ad campaign. A summary report that includes data from many different users can help you learn this information. However, before the data is reported to the ad tech, we add noise as a privacy protection. For example, a summary report can tell you that the ad campaign 1234 on the publisher's site has led to a spend of about $3,972 on the advertiser's site. The value of $3,972 is the noise aggregated data that an event-level attribution report does not tell you. First, let's consider the right way to construct these summary reports and add noise. To generate a summary report, individual conversion reports from devices or browsers are collected and batched to be processed in the aggregation service. There may be hundreds of individual aggregatable reports with the spend values like $21 and $157 sent from each device or browser. These individual values are aggregated in the aggregation service, which amounts to the total of $3,707. However, this exact aggregated total spend value is not available to the ad tech. Instead, before the aggregated value leaves the aggregation service for reporting, noise is added as a privacy protection. In this example, the value reported to the ad tech is $3,972, which is the aggregated value of $3,707 with noise added. Similar to how randomized response worked before, adding noise to this value masks each user's contribution to the total value. But the important difference here is that the noise is added to the total and not each individual conversion. This can allow for more accurate reporting while still providing similar privacy protections by taking advantage of both aggregation and noise addition. To aggregate values across multiple devices or browsers, we want to add noise once in a centralized location rather than adding noise to each conversion event on device. But how can we add up the reports without telling anyone the value in each report? To do this, we need to have a way to extend the boundary of computation beyond the device without leaking any additional information to the ad tech before the final summary report is ready. To do this, we'll use a Trusted Execution Environment, or TEE, to allow us to securely aggregate reports from many devices and add the right amount of noise before releasing the results. A TEE consists of software and hardware components, and it runs in a cloud environment that provides its own set of security measures. A TEE enables code execution in a secure area on a CPU that is isolated from the main operating system and other applications. The key value service and the bidding and auction services are other Privacy Sandbox services that run in a trusted execution environment. A TEE provides a level of assurance in data confidentiality and data integrity, meaning data in a TEE cannot be observed or modified by any other processes running on the host machine. And code integrity, meaning that the code that runs in a TEE cannot be modified by any other process. Because the trusted execution environment is able to provide these key properties, we're able to expand the computation boundary to allow individual conversion reports to be collected on device and then sent to the aggregation service running in a TEE for processing. And when that data leaves this expanded computation boundary of on-device and TEE, we can be confident that the right amount of noise has been added. Distinguishing computation boundaries and privacy protections help us determine where the cross-app or cross-site data processing occurs and how that data should be protected as it leaves the boundary. Using TEEs to extend the computation boundary beyond the device opens up a new option for providing private and useful data. Let's take a look at another example: protected audience. The Protected Audience API allows you to use data from one app or site to render an ad when the user is visiting another app or site. Protected Audience initiates the auction on device, and that is one of the computation boundaries where cross-app or site data is handled. And that computation boundary can be expanded with the uses of TEEs again, similar to what we saw with the aggregate attribution reporting. During a protected audience ad auction, the device or browser makes a request to the auction participants' servers to retrieve real-time information. This real-time information can be used by buyers to calculate an ad bid or by sellers to provide a desirability score for that bid. Without the usage of the key value service, it would be hard to react to real-time changes, such as stopping an ad campaign where you've spent all your advertising budget. By using TEEs to expand computation boundaries, we're able to provide access to real-time information in a more practical manner to the auction participants. Another way that the Privacy Sandbox on Android is addressing cross-app or cross-context data sharing is the SDK runtime. SDK runtime is a mechanism where Android app processes and the ad tech SDKs which they rely on are installed and run in a discrete execution environment so that the data they have access to can be better controlled. So, while the app and its advertising SDK can communicate using APIs, each process has its own set of user permissions and separate resources that are inaccessible to the other. Prior to the introduction of the SDK runtime, the expectations across the Android ecosystem was that, like most operating systems, packages included inside of Android applications would inherit the permissions of the apps themselves. These may include privileges and permissions granted to the host application, such as location services, as well as having shared storage elements and access to the same device data. For app users, permissions such as read and write to calendar are not granted to the SDK in the runtime, while the app code in the app runtime can continue to use the permission. For advertising SDKs, showing ads UI from a separate process helps to reduce some forms of ad abuse. For app developers, having the SDK run in a separate process gives the ability to handle SDK ANRs more gracefully without having to crash the app. Currently, SDK runtime is feature scoped for SDKs which will be used for advertising, granting them data access necessary to carry out their critical use cases. Additionally, separation of storage components under the SDK runtime is an important step towards limiting cross-app tracking mechanisms. It does so by removing an existing pathway through which SDKs can store and access unique identifiers inside of the shared application storage. Now, I'll pass it off to Rob to give us an update on what has been added to Privacy Sandbox in the last year to help further the goal of improving user privacy.
Thanks, Kevin. We are always looking for ways to better protect user privacy, and we want your input in improving our privacy initiatives. Now that we've seen how the Privacy Sandbox improves user privacy from the status quo, let's take a look at what's new with the privacy-preserving APIs. Privacy Sandbox is a constantly evolving initiative, taking both feedback from the ecosystem and the latest results from our testing and ramp-up of new features into account. We've made a number of additions and improvements to the APIs in the last year. The Topics API on Android, an API that delivers user interest categories based on the footprint of applications that a given SDK has a presence in, is receiving an update to add encryption functionality. The goal of encryption is to ensure that the topics results are only readable by the SDK that is requesting them. Ad techs calling the Topics API will need to follow steps to set up their topics public-private encryption keys, which can then be used to decode the encrypted topics data. Once initial testing has been completed, the current plain text topics will no longer be returned. For more information, please check out the Topics API Explainer. Next up is the SDK runtime. We've talked about how the separation of processes and storage assists with our privacy objectives, but we've also been making improvements to the process for implementation on the app developer side. Most notably, in the last year, we've introduced the SDK runtime shim library, a Jetpack library to standardize and abstract lower-level dependencies when building APIs for SDK to app communication across the separate processes of app and SDK Sandbox. In addition, we've greatly simplified the way apps show ads-related UI from the SDK runtime with the help of the UI Jetpack library. And lastly, to standardize the way SDK developers build their runtime-enabled SDKs to run seamlessly on older versions of Android, we have released the Jetpack backwards compatibility library. We've gone over the basics of attribution reporting when talking about computation boundaries and summary reports, and we have added new features to cater to even more use cases. We recently released flexible event reporting, which allows ad techs increased control over the structure of their event-level reports, such as giving the option to reduce the amount of total noise by decreasing trigger data cardinality. This will help ad techs get the maximum utility from their reports. Lastly, Android has made other additions to further support the mobile app ads ecosystem with the introduction of protected auction using the bidding and auction services and the latest edition, protected app signals. Bidding and auction for Android enables a streamlined process for considering contextual, remarketing, and app install advertising demand through a unified auction, also known as a protected auction. The protected auction is executed in a secure environment on the cloud in trusted execution environments. Protected App Signals provides a way for developers to store custom signals from apps the user has opened. These signals are sequestered into a secure environment on the device and not readable by the developer. During the process of a protected auction, these signals are accessible only to the delegated buyer's bidding and auction service running in a TEE. This way, buyers can run their bidding logic with these signals without relying on a cross-app identifier to join them. Similarly, Protected App Signals helps to remediate some of the signal curation issues that come as a result of moving away from cross-app identification by giving developers a means to create and store custom signals aligning to the user information they need for the app install targeting use cases. An example of this might be storing a signal to indicate that a given user has made it to a certain level in a mobile game. An ad tech could create and store a signal indicating this and iterate on it each time that user is active in one of the games they have a presence in. They could then combine this data with another signal indicating how much that user is spending on in-app purchases to determine what kinds of other games they may be interested in. An important question web, app, and game developers often ask about the Privacy Sandbox is, where do we fit into this? The products and services created by developers in the mobile and web ecosystems are what makes these spaces such an important part of all of our lives. And asking such a massive and vital community to make sweeping changes is as challenging as it is crucial to building a more private future. Our approach has been to build solutions to make the most progress towards these goals, while letting the majority of developers make little to no direct changes in how they implement offerings of their ad tech partners. In order to achieve this, our partners in the ad tech space have spent several years working with us to test and refine the Privacy Sandbox offerings, which preserve critical ecosystem use cases, while improving the privacy of users on mobile and the web. Most of the work that developers will need to do in order to prepare for the Privacy Sandbox is to make sure that they are adequately maintaining their web and mobile offerings according to the latest practices and tooling made available. For most developers, this should ideally be the standard already, with the majority of the specific Privacy Sandbox work coming in the form of updates to existing ad tech SDKs. Now, back to Erin for what you can do today to get involved with the Privacy Sandbox.
Implementation of privacy-preserving APIs is primarily the responsibility of the ad tech developers, but it is crucial that the rest of the ecosystem speak up in a collective voice to advocate for a more privacy-centric approach to advertising. First, we encourage you to get educated about privacy-enhancing technologies by reading published documentation and giving feedback where appropriate to be a part of the conversation about the most effective ways to improve privacy across mobile and web. Then, get in touch with your ad tech partners about using Privacy Sandbox on Chrome and Android. It's of the utmost importance that our ecosystems move forward together in building these solutions. And the best way to ensure that is to take an active role in advocating for it. Ad tech developers who are not already testing or implementing the Privacy Sandbox should consider getting started. Involvement in testing and early adoption are the best ways to ensure that your critical use cases are accounted for, and that you'll have the smoothest possible transition to using these tools as time goes on. From all of us on the Privacy Sandbox team, thank you for checking out our talk. And for more info on the Privacy Sandbox, check out our developer site, as well as other content from this year's I/O.